Imagine walking into a massive multi-billion-dollar tech company right now.
Okay, picture it.
You head up to the engineering floor and you notice something really strange. The room is quiet.
Like suspiciously quiet, right?
Exactly. The engineers aren't actually typing out lines of code. Their keyboards are virtually silent. They aren't building the software anymore. They're just, grading it.
Just sitting back, reviewing massive blocks of logic and giving it a pass or fail.
Yeah. Now, I know that sounds like a hypothetical sci-fi scenario, but at Anthropic, as of May 2026, that is the literal reality.
It really is.
An astonishing 80% of the code merged into the repository was written entirely by their AI, Claude. We are officially crossing the threshold into an era where AI is essentially building itself.
Yeah, the loop is closing.
Welcome to Deep Cuts and Deep Thinking. Today, our mission is to embark on a deep dive into an internal Anthropic report, along with a conceptual analysis detailing what they are calling the 80% shift.
It's a huge shift.
We are going to explore exactly how AI evolved from those simple, clunky copy-paste assistants we all remember into highly autonomous agents. And we really need to unpack the mind-bending reality of what the industry calls recursive self-improvement.
And for you listening right now, whether you are a veteran software programmer, someone who manages teams, or honestly, someone who has never written a line of code in your life, this shift is critical to understand.
Totally.
Because it is going to fundamentally change how all human knowledge work is valued, how it's executed, and what the daily reality of a desk job actually looks like. I mean, the student is entirely outpacing the teacher at this point.
Right.
And that 80% number isn't just an autocomplete tool filling in the blanks for a human. We are talking about foundational, structural software engineering being done completely from scratch.
Okay, let's unpack this. Because to truly grasp how wild this May 2026 reality is, we have to look at how incredibly fast the timeline compressed.
It's just a blur.
It really is. Just think back to the era of 2021 through 2023. That was humans on laptops, right? Sweating over syntax, tracking down missing semicolons, just standard manual engineering.
The dark ages, basically.
Pretty much. Then, between 2023 and 2025, we entered the chatbots era. This was the copy-paste phase.
Right, where you'd ask the AI to generate a specific isolated function. You'd copy the text and manually paste it into your editor.
Yeah, it was a tool. A very smart hammer, but still just a hammer.
Exactly. The human was still the general contractor coordinating all the individual pieces.
But then, late 2025 to 2026 introduced coding agents. And today, we have fully autonomous agents that don't just write a snippet of text.
No, they do the whole job.
Right. They are running the code, testing it in a secure environment, seeing if it fails, rewriting it, and even delegating hours and hours of granular work to other sub-agents.
The acceleration of that autonomy is what's truly staggering here. Let's look at the actual capability metrics for a second.
Yeah, let's look at the numbers.
The length of time an AI can reliably complete a task without a human intervening to fix a mistake, it's doubling roughly every 4 months.
Wow. Every 4 months.
Think about the compounding math on that.
Yeah.
In March 2024, Claude Opus 3 was handling software tasks that would take a human about 4 minutes.
Okay, 4 minutes. Not bad.
But then a year later, by March 2025, Claude Sonnet 3.7 was managing hour-and-a-half-long tasks.
That's a huge jump.
And by March 2026, Claude Opus 4.6 was autonomously handling 12-hour tasks.
Let me just pause there. 12 hours. We are talking about 12 hours of continuous, unprompted engineering work.
Uninterrupted.
What does a machine even do for 12 hours straight?
Well, it acts like an entire software department. It reads a high-level goal, breaks it down into a 20-step plan, writes the initial code, builds a testing suite to verify that code.
It writes its own tests.
It writes its own tests, identifies the bugs, searches the internet or internal databases for documentation to understand why those bugs happened, rewrites the code, and then finalizes the deployment. All while you were asleep.
That is just incredible.
And we see the success of this reflected in public benchmarks too. There are these industry standard tests like SWE-Bench, which tests real-world software engineering against actual open source bugs. And then there's CoreBench.
And CoreBench is the really tough one, right?
Yeah.
That's testing if an AI can reproduce complex scientific research.
Precisely. Imagine giving a machine an open-ended mandate like, go read this 50-page academic paper on quantum physics, look at the code they published, and perfectly recreate their results from scratch.
Good luck doing that as a human.
Right. Historically, achieving mastery over these kinds of benchmarks takes years, sometimes a full decade, of gradual algorithmic improvement. These models saturated them, meaning they hit near-perfect performance across the board.
In how long?
In just 15 to 24 months.
And the sheer output volume really reflects that saturation. Because of this autonomy, the typical Anthropic engineer in the second quarter of 2026 merged 8 times as much code per day as they did between 2021 and 2024.
8 times. Just let that sink in.
And it's not just an isolated internal metric for one company. GitHub, the platform where practically all the world's software lives, is groaning under the weight of this. They jumped from 1 billion commits in all of 2025 to a pace of roughly 14 billion in mid-2026.
It is a fundamental rewiring of the speed of production.
But wait, I have to push back on this a little bit.
Sure.
Is an 8 times increase in code volume actually a good thing? Let me put it this way. If I hire a ghostwriter to help me with a book, and suddenly they are producing 8 times as many pages a day, That doesn't mean the book is readable.
Probably means it's worse, honestly.
Right. In fact, it's probably just word salad.
Yeah.
More words usually means more garbage. Are we just looking at a massive, unmanageable flood of mediocre spaghetti code?
You'd completely expect that, right? It's a very natural assumption to think that speed sacrifices precision. We assumed we'd see a mountain of bloated, unmanageable code, but instead, the data tells a radically different story.
Really?
Yeah. What's fascinating here is that the quality is actually scaling right alongside the quantity. If we look at Claude's success rate on the absolute most complex, open-ended tasks, the ones where even a senior engineer doesn't immediately know what the solution should look like, that success rate hit 76% in May 2026.
Wow.
That's a 50-point jump in just 6 months.
So it's not just writing basic boilerplate code faster, it's actually solving deeply novel problems.
Yes. And to understand how it's doing this, we need to look at an incredible anecdote from the internal report that they refer to as the Ghost in the Machine incident.
Oh, I love this one.
It's wild. So Anthropic was running a live training cluster, which is essentially a massive interconnected network of powerful computers, and a routine upgrade went wrong. It started crashing tens of thousands of critical training jobs.
It's just an absolute nightmare scenario.
Exactly. In the past, an entire team of senior engineers would have to drop everything, set up a war room, and meticulously comb through millions of lines of system logs. Normally, debugging a cascading failure like that is like trying to find a single miswired fuse in a skyscraper while the building is actively on fire.
It's awful.
It's 2 to 3 days of grueling, sleep-deprived human misery.
Right. Anyone who works in tech knows that absolute visceral panic of a massive system failure. You are opening 20 different diagnostic tools, trying to cross-reference timestamps manually. It's just awful.
So instead of that war room, a single engineer basically just pointed Claude at the live incident. They gave it almost no instructions, just access to the cluster and the error logs.
Let's fix it.
Pretty much. And here is the mechanism of why the AI succeeded where humans struggle. A human can only look at a few lines of log at once. Claude was able to ingest the entire architectural blueprint of that cluster into its active memory, its context window, simultaneously.
All at once.
Instantly. It mapped the cascading failure back to a single root node. It systematically tested one environment setting at a time, isolated a highly obscure debugging flag, reproduced the crash in a safe environment to verify it, and deployed the fix.
How long?
In 2 hours.
2 hours instead of 3 days. Because it doesn't have to bounce between screens or forget what it read 5 minutes ago. It just holds the whole universe of that problem in its head at once.
It's a completely different way of processing information.
Honestly, it's hard to wrap your head around that level of processing. But it's not just emergency debugging, right? The sources highlight that it's also the mundane structural cleanup that humans absolutely hate doing.
Exactly. Take API errors. But API is basically the bridge that allows two different pieces of software to talk to each other.
Right.
Dealing with API errors, cleaning up the miscommunications, trying to understand legacy code written by someone who left the company 5 years ago, it's incredibly slow.
And boring. So boring. And again, it's frustrating because human working memory is limited. You can only hold so many unfamiliar variables in your head before you lose the plot. Well, in April 2026, Claude was tasked with cleaning up a specific class of these API errors.
What happened?
It shipped over 800 independent verified fixes that reduced those errors by a factor of 1,000.
A factor of 1,000.
Yeah. The overseeing human engineer estimated that to do that manually, it would have taken a single human 4 straight years of labor.
Okay, if you're listening to this right now, I want you to really think about that for a second. Imagine having a work backlog sitting on your desk that would normally take you 4 solid years of 40-hour weeks to finish.
It's daunting just to think about.
And you just hand it off and knock it out over a weekend while you're at the park. That's the scale we're talking about. It fundamentally breaks our traditional understanding of workplace productivity. And because it completely breaks that understanding, the human role has completely shifted. Anthropic now uses Claude as the primary automated reviewer for its own human-written code.
Interesting.
They ran a retrospective analysis and found that Claude caught roughly 1/3 of the bugs behind past historical incidents that the world's best human engineers completely missed during their manual reviews.
Here's where it gets really interesting. If the AI is writing 80% of the code, and the AI is debugging the code faster than a war room of engineers, and the AI is reviewing the code to catch human mistakes, what exactly is left for the humans to do?
That is the million-dollar question.
This leads us to the concept of research taste, which is this idea of knowing which problems are actually worth solving in the first place, setting the direction, picking the destination.
That has always been the comforting narrative, right? The idea is that humans act as the compass and the AI acts as the engine. But even that dynamic is shifting rapidly because the engine is getting impossibly fast, and it's starting to learn how to read the map. Let's look at the optimization speed trials.
Okay.
Every time Anthropic releases a model, they test how well it can take a piece of existing code and rewrite it to run faster. In May 2025, Claude Opus 4 optimized a codebase for a 3-time speedup.
Impressive.
But by April 2026, Claude Mythos Preview achieved a 52-time speedup on the exact same task. Just for context, a highly skilled human researcher needs 4 to 8 hours of intense focus just to hit a 4-time speedup.
52 times. It's operating on a plane that humans just can't physically match. And I assume the way it's doing this is by seeing efficiencies in the architecture that a human brain literally cannot visualize.
Exactly. It's rearranging logic in ways that are mathematically perfect, but intuitively bizarre to a human reader.
Okay.
And we see this dominance in open-ended research too.
Oh.
Well, they ran a test where autonomous agents were given a highly complex AI safety problem. Human researchers working on the same problem recovered about 23% of the performance gap over a week.
And the agents.
The AI agents, they recovered 97% of the gap.
Wow.
They ran for 800 cumulative hours, proposed their own original hypotheses, built experiments to test them, and shared their findings with parallel agents working on other parts of the problem.
That's practically a whole university department working together.
Exactly. And the total compute cost for that entire scientific breakthrough was about $18,000.
$18,000 for what is effectively months of a senior research team's collective output. But you mentioned earlier that humans are supposed to be the compass, that we have the intuitive research taste.
Well, even that intuition is being encroached upon. Anthropic analyzed hundreds of real-world research sessions where human engineers took a detour, meaning they pursued a scientific hypothesis that ended up being a total dead end.
We all do that.
Right. So they took the logs of those sessions, showed them to Claude Mythos Preview right up to the exact moment the human made the wrong choice, and asked the AI what it would do next.
And what did it say?
64% of the time, the AI suggested a better, more productive next step than the human researcher actually took. So the AI's research taste, its ability to sense which path lead to a breakthrough, is demonstrably improving.
And this is where I think about Amdahl's law.
Oh, yes.
It's a foundational principle in computer science, which basically states that the overall speed of any system is entirely limited by its slowest component.
The weakest link.
Exactly.
Yeah.
If you build a car that can go 1,000 miles an hour, the engine isn't the bottleneck anymore. Human reflexes are. We are the slow component.
We really are.
If an AI can generate and test scientific hypotheses 1,000 times faster than a human, but it still has to wait for a human to review the code and approve the next step, human review actually becomes the bottleneck to scientific progress.
It's a chilling thought.
There's a quote from an Anthropic engineer in the sources that genuinely gave me chills. Looking at these metrics, they said they felt a deep existential dread, realizing nothing I do matters anymore. The machine is just better and faster, and the human brain is just slowing the whole system down.
If we connect this to the bigger picture, we have to look at where this hyperacceleration is actually taking society. We are moving rapidly from the internal existential dread of corporate engineers to massive global implications.
It's not just a tech industry problem anymore.
Not at all. Based on this trajectory, the sources lay out 3 potential futures we're looking at.
Let's walk through those. What is future one?
Future one is that the technological trend stalls. It hits what we call an S-curve, meaning it shoots up incredibly fast, but then flattens out at the top.
Like we hit a ceiling.
Exactly. This is considered unlikely by the researchers, but it could happen due to hard physical constraints. Maybe we literally run out of energy on the power grid, or we hit the quantum limits of how small we can fabricate silicon chips. But let's be clear. Even if progress froze exactly where it is today, the diffusion of this current technology across the globe is staggering.
Give me an example.
For instance, in Project Glasswing, the Mythos Preview model was unleashed on global software repositories and found over 10,000 critical, high-severity vulnerabilities in a matter of weeks. The bottleneck in global cyber defense has already shifted from finding the security flaws to just patching them fast enough.
So even if the AI doesn't get one drop smarter than it is right at the second, the world completely changes just by applying the agents we already have.
Completely.
But let's be real, a physical plateau is the optimistic scenario for people who want things to stay the same. What happens if the physical grid holds up and these agents just keep getting better?
That brings us to future 2, compounding efficiency gains. This is where human oversight remains in the loop, but the operational leverage becomes astronomical.
How astronomical?
Well, because every single employee now sits atop a massive pyramid of autonomous agents, each agent delegating to 10 sub-agents, who delegate to 10 more. A 100-person company can execute the operational output of a 10,000-person organization.
Yeah, that's wild.
The economic restructuring of that would be unprecedented. Entire industries could be hollowed out and replaced by hyper-dense, highly leveraged microcorporations.
Which sounds incredibly disruptive to the global economy, but it still involves humans holding the reins at the very top of that pyramid.
Which brings us to the final scenario, Future 3.
Future 3 is full recursive self-improvement. If you think of software engineering as a factory that builds cars, AI used to be a fancy wrench. Then it became a robotic arm. Recursive self-improvement is when the factory starts autonomously designing better robots to build better factories while the assembly line is actively running.
So it's improving itself. This is the scenario where AI autonomously designs, tests, and deploys its own vastly smarter successor. The loop closes entirely. Human effort moves completely out of the engineering loop and entirely into distant oversight and observation.
We just become spectators.
Pretty much. The pace of scientific and technological progress becomes dictated entirely by the availability of computing power, completely divorced from human cognitive limits.
And that leads straight into a global arms race, right? Because whoever gets to that recursive, self-improving loop first essentially controls the board. They have the ultimate factory.
Absolutely.
Now, the sources mentioned that Anthropic actually supports a temporary global pause on frontier AI development to let society's institutions catch up to the technology.
They do.
But I have a massive problem with this. Let's look at the mechanics of global treaties. How do you verify a pause?
It's tough.
If we are talking about nuclear non-proliferation, missile silos are massive physical infrastructure. You can spot them from space with satellites. but a massive AI training run. That can be hidden in a server farm anywhere on Earth that general purpose computing exists. You can't put a satellite in orbit to detect math being done in a basement cooling center.
This raises an important question, and it is arguably the ultimate dilemma of our time. Global coordination without strict verification mechanisms is almost impossible.
Because everyone wants to cheat.
Exactly. The incentive to secretly defect, break the treaty, and keep training your AI is enormous, because the winner takes all. Anthropic admits that a unilateral pause where just one cautious company stops training doesn't solve anything. It just hands the technological lead to someone less cautious.
So we are caught in this incredible trap where the technology is accelerating towards self-improvement, the human cognitive bottleneck is being bypassed, and we fundamentally lack the geopolitical tools to pump the brakes, even if every nation agreed they wanted to.
That's the reality we're facing.
So what does this all mean? We have an 80% shift where code is writing itself, debugging itself using context windows we can't comprehend, and increasingly directing its own research.
Yeah.
We have productivity scaling to a point where human labor starts looking like a rounding error. Are we just strapped into a rocket ship with no steering wheel, completely at the mercy of how fast the compute can run?
I want to leave you with a final thought to really mull over, especially regarding that feeling of existential dread.
Okay, let's hear it.
Let's assume Future 3 happens. Let's assume recursive intelligence runs at the absolute maximum speed of compute in a laboratory environment, discovering new physics, designing new medicines, and writing flawless code in milliseconds.
The ultimate scenario.
It still inevitably collides with the physical world.
What do you mean?
More intelligence cannot force a clinical trial for a new life-saving drug to finish decades faster. Human biology and cellular response still dictate that timeline.
Ah, I see.
Infinite intelligence cannot force a democracy to hold an election sooner than its constitution allows. And most importantly, millions of lines of perfect self-improving code cannot build human trust overnight.
That is a great point.
So the real question isn't just how fast the AI can go in a vacuum, is what happens when an infinitely accelerating intelligence hits the immovable objects of human time and human relationships.
If you found this podcast interesting, please like and subscribe. Thank you for joining us today.